number of participants on the call already. So the first session I want to kick off here is from Wolfgang from Elektrobit. So Wolfgang, I'll let you do your introduction and kick off the session. Thank you very much.
Fantastic. Thank you, Rob. Let me grab the screen here real quick. Yeah. First of all, thank you for having me here today and also the ability to kick this off. My name is Wolfgang Thieme. I'm head of product management for cloud and systems at Elektrobit. Topic of this first session is scalable testing of automotive software in the cloud. So let's go right into it. Maybe first a little bit of ground setting the context. Who's Elektrobit? Since 5 years, we are a wholly owned subsidiary of Continental, one of the largest tier 1 suppliers in the automotive industry. And Elektrobit is solely focused on developing and providing in-vehicle software for our customers. So that's the core of our business, the software that goes into the car. We do that with kind of two organizations. So we have a service organization, we have a product organization, and essentially they work hand in hand together to provide the products to our customers. Our software moves the world is kind of the slogan. We have around 5 billion embedded devices today on the street running our software. As a subsidiary, we're not as big as Continental, of course. We have around 4,000 people worldwide. Products and services is our core. We have experience in the automotive industry for decades, 35 years. We're strong in cooperation. So we are working obviously with Continental and have also an additional arm that deals with cybersecurity in particular for the automotive industry. We do pride ourselves with very long-term partnerships with different OEMs out there, and of course, quality culture. Like our software really is important in the car. It's critical to run the car. So quality culture is very important for us. We do safety critical software. Just one word around where we are. Of course, we are a global company, even as a subsidiary of Continental. We have offices around the globe, typically close to the big OEMs to provide the optimal service. So that's for a quick introduction of Elektrobit. Let's talk about the challenges in the automotive industry and see what drives us there. So the paradigm shift towards the software-defined vehicle. That's obviously one of the main driving factors in the industry right now. So I don't know, maybe some of you already saw these graphs, million lines of code that are out there in the car and ever growing. So today we have 100 million lines, 200 million lines of code in the car, and this gets updated. This gets even more with more advanced driver assistance systems and more advanced algorithms that are shipped with the vehicle. Customers expect updates throughout the lifetime of the vehicle. So the software in itself gets more and more and more, needs to be constantly updated and maintained throughout the whole life cycle. The software-defined vehicle kind of describes that shift away from an engine and mechanics more towards the software and the software side of it that defines really the value of the car. At Elektrobit, we kind of try to focus on three topics in that context. That's the Automotive OS, software lifecycle management, and cloud-first workflows. So the Automotive OS is what we describe a software platform that enables the use of the different software components in a vehicle across a platform, across brands of an OEM. So you don't want to start all over again with developing the software from the ground up. You want to reuse as much as possible in the different cars that are offered. So the Automotive OS brings all of that together, defines APIs to develop your applications, the OEM's applications against it. Typically, the Automotive OS is kind of referred to as non-differentiating software or middleware in the car. So essentially, everything that is building the foundation for the apps that run in the car, for example, for your IVI or infotainment system. The software lifecycle management becomes more and more important. The old frozen version support is not a good answer anymore. As I said in the beginning, there is updates, constant updates in the car required, and that's not just one, right? So we talk about life cycles of a car of 10 plus years. So we as Elektrobit, we need to provide updates for our software components for that time frame. And it gets more difficult as new regulations come into effect. Cybersecurity as one of the most prominent ones. Essentially, you need to fix cybersecurity issues in the software in the life cycle of the next 10 years. So that's why software lifecycle management is a key to success in this software-defined vehicle journey. And number 3, cloud-first workflows. That's how we call it. Obviously, developing and delivering all that software to the OEM or to the tier 1s gets more and more challenging. We need new processes, new methods, new approaches to deliver that software, develop that software. And this is where cloud, from our perspective, plays a pivotal role in getting that done. Let's focus a little bit more on the cloud-first approach and what that actually means. It's all about automation and scalability. So extendable frameworks, working with APIs, connecting to different services that we develop ourselves at EP, that we develop in the Continental Group, but also to external companies and as well. Collaborate across suppliers, teams, locations, time zones is a constant challenge for us. Again, cloud comes in, that's always available. Scalable resources is a very important point. You don't need always all the processing power that you might need for a simulation of an ADAS system all the time, like idling in your basement. You can just use it on demand. And of course, availability 24/7. Virtualization, and I'm gonna dive into virtualization a little bit more in a second here. Virtualization really is one of the key enablers of these cloud-first workflows. Virtualization means the virtualization of an electronic control unit, the ECU, basically these small black boxes you have in your car that do some functionality in that vehicle. And there's a bunch of them in the car, around 100 right now. So virtualizing that is key to optimize these workflows. Bit parity is a very interesting topic, and a topic that is also covered in the SOFI initiative, industry consortia that's working together to enable this. Essentially, you develop software in the cloud, and You build it in the cloud, test it in the cloud, and you flash the same software onto the so-called target, onto the ECU itself without any changes. That is what's meant with bit parity, so no additional changes to the software. Of course, testing is a huge thing that needs to happen in automotive specifically. We have also the whole chapter around DevOps, operating the platforms, maintaining the platforms, harmonizing the development environments that we use internally, that our customers use, so you can kind of circumvent problems that two developers set up their environment a little bit different and then go chasing bugs that are not really caused by their software, but by a misconfiguration of their development environment. And of course, automating the whole thing with CI/CD and CT pipelines. Testing again is a very important aspect. As I said already, virtualization is key for us to accelerate the development in automotive. It's what we call like also shift left. So we want to test and develop more in a pure software environment and get that close connection to the embedded hardware, to the real ECU, loosened a little, to be more independent from hardware constraints, chip shortages, obviously, but also it enables us to scale to much more developers than you can scale with 10 development boards too. So virtualization is key in that journey, and key to loosen the hardware dependency. So just as a little bit of a side note, in reality, these ECUs or test boards, they get shipped around at an OEM from person A to person B from time to time because there's not enough there, right? So you're waiting in a worst case scenario, you're waiting for your package to arrive 2 days later to test your software component just to ship it back to the other guy so he can verify his next update. So virtualization again tries to loosen that hardware dependency. Of course, it comes with a bunch of other benefits. You detect bugs earlier than in your traditional V model development approach. You can run simulations and tests faster than real time. That's different from an ECU target. 10 times, that's what I put here on the slide. There's also 100 times or 1,000 times that you can run the simulation faster. And of course, again, it's available 24 hours. It's available around the globe. Every time you need it, it's there. So to level set a little bit, and I know that in this session there's also participants from other industries, just touching real quick on ECU and AUTOSAR. What's an ECU? ECU, as I said already, it's electronic control unit, and I basically want to tell you a little bit what goes into one of these ECUs. So there's a bunch of software that goes in, from hardware drivers, different operating systems, of course your application like your lane assist, and then there's also the configuration, how that specific black box talks to the other 100 boxes that are in the car. So kind of an ECU configuration. So there's a lot of software that ends up in that ECU, and that is only 50% of the whole thing. The other part is testing. You need to do module tests, integration tests, validation tests, functional tests. Does it even detect the lane, right? So all of that go into one ECU project, and it's not necessarily that one supplier builds it all. There is multiple suppliers working on different parts of that ECU, Maybe one is only supplying the application, the other one is supplying the hardware drivers or MCALs, the other one is supplying the operating system, and the next entity is doing the testing. So there's typically a lot of people involved in building one of these ECUs. Cost and time-wise, 50% for software and development, and the other 50% is just the testing and the integration part of that journey. And of course, everything needs to comply to the regulatory requirements of that system in particular. ASIL B and D for safety or functional safety, ISO 26262. Cybersecurity we already talked about. That's the UNR 155. So there's a lot of different requirements that kind of condense down onto this particular hardware box. And again, I'm trying to be very focused on these hardware boxes as we move into that cloud testing journey as an opposite or new way of doing things. Anyways, so the left side here, the whole different like software blocks and so on, that is where AUTOSAR comes in. To those of you who don't know AUTOSAR, huge organization that aims to standardize base functionalities in the automotive industry or in ECUs itself. Obviously, all big OEMs, almost every OEM is part of AUTOSAR, is member of AUTOSAR. There's over 350 of specialized and best-in-class companies that are members of that AUTOSAR consortia. Again, the goal of AUTOSAR is to get rid of this upper box here on the right side, the dependency of hardware and software, and basically put a hardware abstraction layer in between, right? So that enables reuse of software components over time. So for your next vehicle generation, for example, but also from vehicle to vehicle or from different ECUs to other ones. So getting that hardware and application and hardware and software dependency and decoupled is also goal of the AUTOSAR consortia. So, and just as a quick fun fact, AUTOSAR is the 20th anniversary is of course this year. So it's a long-term industry consortia that is well proven in the market. Okay, so let's get a little bit deeper into the scalable testing, and for that I picked a real-world example. It's an electric drivetrain. So SD, software-defined vehicle development in action. That's what it's called. So the electric drivetrain consists of two ECUs, a vehicle control unit, and a battery management system. So what's the journey of the developer? A lot of these applications in the automotive industry that run on top of on one of these ECUs is actually done in a model-based approach. So you have some building blocks, you put it together, you have your new algorithm, for example, as in this case, to control the charging current of your battery depending on the temperature. So there's a new model that is developed, the engineer tested the model and has verified it works. So now, if you remember 2 slides before, I showed you all these components that go into the ECU. So the configuration of the ECU, the middleware, the hardware drivers, all these things. So that's typically something the application engineer does not have available. So he knows his application works, but only in his environment. So what he now wants to do is to put it all together with road-ready stacks. And this is in the end where Elektrobit comes in. We are providing these stacks for electronic control units. Typically, there's two. There's a classic AUTOSAR, that's for hard real-time requirements, very safety critical systems, ASIL-B. And then there is adaptive AUTOSAR, that's the more modern standard that is based off of a Linux operating system. So you typically have these kind of two stacks depending on your application. Here we have both of them. So the application gets deployed onto the various stacks, or the different applications get deployed onto the different ECUs. One is measuring the temperature, the other one is taking that input and adjusting the charging current for the battery. And we do all that in the cloud on AWS. And that's a paradigm shift from what was done before. I showed you these ECU boxes with a purpose. This is typically where your software ends up on, right? So you build your model, you compile it all together, you flash it on your hardware that's typically sitting on your desk in front of you, and then you figure out something is not working. And there's only so many hardware boards available, or you have an engineering sample that's only there's only one, and your colleague has the cables, and all these real world problems. So what this enables is to develop completely independent from hardware and essentially do your complete system test in the cloud. So you can check your models, you can check your signals, you can check your sum IP communication between the two instances, and shift left, shift as much as possible testing towards your cloud deployment of your system. So the title of this whole presentation is Scale It. So let's scale it. We have a development environment that is running in the cloud, so a developer can just connect to it with a Visual Studio Code. He has all the tools already pre-configured and available there. He can build his new application, change configurations of the base software, check it into GitHub, and a step functions kicks in to build the rest. Build a virtual ECU, deploy that virtual ECU in a simulator. In this context, we use, for example, Synopsys Silver for that classic ECU, and spin it up. We have our own test framework that's called ABETA, integration test automation, and that runs tests against that virtual ECU. So now the advantage of doing that in the cloud, obviously, is you can spin up 1, 2, 5, 100 of these instances and accelerate your testing that you want to conduct. Just from a practical standpoint, there is tens of thousands of tests that are run in a classic ECU project from time to time. It's always depending on the size of the project, but there's a lot of tests that are typically run every night, every build against an ECU. You can also, of course, automate it in a way that you build the real binary in parallel and flash it onto a real ECU to compare the results. So looking at the time here, I think we are pretty close. Let's do some wrap up. So obviously, software-defined vehicle comes with a massive amount of software that's even growing down the road. To handle this, there's new tools, new methods, new processes required to deliver all that software. This is where we see cloud is a huge contributor to this automation and scalability, and gives us a lot of freedom in developing faster. And in the end, industry collaboration. AUTOSAR is one example of an industry consortia, but also SOFI, where EB is also a member that tries to bring together the car and the cloud world even closer together to really enable that bit parity development in the cloud, so you can always deliver the most up-to-date software to your customers. And with that, I think it's on the point here. So open, thank you, and open for questions.
Thank you, Wolfgang. A wonderful presentation. But I can start off with something which came to my mind. I mean, it was amazing to see that we have like hundreds of millions, so 200 million plus lines of code in the vehicle, much more than a spacecraft or a Dreamliner possibly. One thing which comes to mind, I think, which some of our customers ask is, how do we test all this with so many players and so many contributors to this code? How do they know that this code is ready for start of production? I think they have this processes for the previous generations of the vehicle, but with so much software, does anything change?
And that's exactly where cloud and new platforms come in, I believe personally. So in the past, and we know that from our daily work with our OEM customers, the integration of these different software components from the different vendors is a nightmare in reality. It's very complex, and not everybody delivers the same quality of code at the same time. So you're running into a huge process just integrating it all together. So streamlining that is one of the keys. Obviously, there is technologies out there that enable that, CI/CD pipelines with automatic delivery to the OEM that then integrates it into his huge test automation framework to kind of build the functional blocks, right? Software-defined vehicle, I think, like the virtual car, here it comes, right? As another buzzword, but in reality, this is really where this needs to go, because otherwise there's no chance in scaling up the testing to the need that is, that we are all happy, right, in the end. So
Thank you, Wolfgang. So we have a question. I think somewhere. Do you want to ask the question?
Thank you, Wolfgang, for the presentation. I was just wondering if those virtual ECUs runs like Android Automotive or Linux or something else.
No, in that example, they were not running Android. Android is typically used for the IVI system. So that was a vehicle control unit that is running an Linux system or a QNX typically. And the other one, the classic AUTOSAR, is typically running a proprietary real-time operating system that is safety compliant. So this example did not include an Android OS for IVI systems.
Thank you so much.
We have one more question from Andre, and then I think we run out of time. Andre, do you want to ask the question quickly? How do we know that the simulated environment is same as the real environment? That's the question.
It's a very good question, because we don't, right? We can only try to work as close as possible to the real environment. So this all here does not replace hardware in the loop testing. In the end, we do need to do some real hard testing anyways. But the goal is to reduce that. The goal is to reduce the dependency, and the goal is to find as much as possible bugs before we go onto the road or into a hill environment. So that's kind of the idea. But modeling the right environment that's another presentation.